Good afternoon, and thank you for being here with us in this webinar organized by Science Communication Hub Nigeria. Today, we are pleased to welcome Dr. Ali Bukar Maina, a very special guest from United Kingdom. Ali is a senior scientist with specialty in computer science and machine learning. He had his PhD in computer vision and machine learning from University of Bradford, UK, and his MSc in computer in software technology and network management at Robert Gado University, Aberdeen, Scotland, and his bachelor degree in electrical engineering from University of Maiduguri, Nigeria. His research work mostly focused on phase-age synthesis progressions, has been reportedly widely by international media such as BBC, CNN, and among others, which aims at helping the society in identifications of missing peoples. Dr. Ali Maina, who will be giving us a talk on introductory course on Python for data sciences, will shortly be with us here. So please join us to welcome Dr. Ali Maina to start the lecture with us. And feel free to make your comments below. There are comment sections. You can ask your questions while the session is ongoing. You can ask questions that you think is relevant, especially in this Python for data science. Feel free to ask more. We are here to appropriately guide you on how to do data science using Python programming. Dr. Ali, you are welcome.
Thank you, Umar, for introducing me. Hi, everyone, and welcome to this webinar. Today, we are going to look at Python for machine learning, and the approach we are going to take is the top-down approach. What we mean by a top-down approach is, without any waste of time, we are going to get a problem, and then we walk you through the problem by solving the problem. So we work together and solve the problem. So instead of teaching you the basics of Python, what we are going to do today is different. We'll just get a problem and then we'll solve it. By doing that, for those of you that are familiar with Python, you will find that this is a straightforward way of getting your hands into real-life problems. While for those of us that are not familiar with programming, this is not something to deter you or to get you scared. But what will happen is that you will see programming, basics of programming put into use, and I'm sure that will instigate you to start learning it. And besides that, whatever we do today, especially if you have a computer, you will be able to save it, and it means that you could continue using whatever we use today for your own specific problems. It means that working together with us today, you will learn how to program, and the program is yours, and you can keep it and then use it for your own specific problems. So without further waste of time, we would like to tell us a few things that we have to do today. So one, we have to find a computer that has Python installed. For those of us that don't know what Python is a programming language that is popularly and widely used today, especially for machine learning and artificial intelligence. The reason why Python has become very popular is, one, due to its ease. It's quite easy to learn. So people just pick up Python within a short period of time, learn how to use Python. And secondly, Python is open source. So everything you use in Python is free. You don't buy any software. You don't buy things or licenses. Python is free, and there are lots of libraries which have been written by the big, huge community that give us the chance to just utilize in just a few lines or just a single line of code, you are able to achieve a lot of work, and you will see it today. So we have decided to choose Python as the programming language of choice today. And then, as I was saying earlier on, we need a computer. If you have a computer with you, I'm sure some of you will be on Windows, some of you will be on Linux, some of you will don't even have Python installed on your computer. And we don't expect you to install Python. That's why we didn't tell you earlier on to install Python. So what we're going to do today is we'll show you a way of accessing free, rich resource, a computer online that our friend Google has given us that has huge RAM size and a very good graphical processing unit, and with all packages installed. In fact, this is what every machine learning engineer or people that are trying to learn machine learning should be using today. Although the capacity might not be big enough for huge projects, but for something that we're trying to look at today, I think using the platform that Google has provided, which is called Google Colab, is going to be helpful for us. Then secondly, once I take us through opening Google Colab, we will then download our data. I'm optimistic all of us have the data. So you will download our data. First thing, we should be able to load our data into the environment. Then next, we should be able to understand our data with a few lines of Python. Then after understanding our data, we'll go on to visualize our data. And you'll see how this is done in Python as well. Then after visualizing our data, then we will go on to do a bit of machine learning. We'll do some prediction. So I feel that this is going to be really interesting. I just hope our time will permit us to walk through everything. So without any waste of time, the first thing we're going to do today is to go download. So it is for us to access the Google Colab. So Google Colab is the platform that Google has provided. And once you have a Gmail account, I hope that all of you have Gmail accounts. For those of us that are using computers, if your Gmail account is already, if you're already logged into your Gmail account, the first thing we're going to do now is so the first thing we're going to do is we're going to go to this link. Go to this link. So we should type this in our web browser. I'll just type this in my web browser. And once you type this in your web browser, it will take you to Google Collaboratory. That is, you can see there are many options. There are examples. So after today, you can come back to examples and see other example codes and how to use Google Colab. There are recent files that you've used. It could also access your Google Drive. For those of us that have code on GitHub, you could also have just pull things from your GitHub account. But without any waste of time, once you're here, once you are all here, you click on New Python 3 Notebook. It will take a moment, but it will load. I'm here. I hope everybody is here with me now. So if you're here, you will see that we have a new Python 3 notebook. Then go to the right-hand side on the top. There is a connect here. Can you see my cursor? There is connect. Click on connect. What this is doing is it's going to allocate some resources for you. Like I said, it's going to give you 12 gig of RAM. And it's going to give you, it has given us 12 gig of RAM. It has given us, and it will give us access to the GPU. If you want to access the GPU, although what we are doing today is not going to be heavy, but just for the sake of learning, if you want to access the GPU, which is a graphical processing unit, what this means is that it is a hardware that allows mathematics computations to move on really, really fast. To access the GPU, come to the left-hand side. There is runtime here. Click on runtime, and then go to manage sessions. Change runtime type. So when you come to change runtime type, you see that we're using Python 3, and then the hardware accelerator is none. You can click on this none and choose GPU. GPU is more powerful than CPU, and it is the hardware that has made machine learning today to realize its potential. So with this, we have our working environment. I'm taking my time so that everyone is going to be with me. So once I have my working environment, the first thing I would like to do is I would like to import some libraries. So there are some Python libraries that we're going to use. Like I told you, Python has so many libraries that make it possible for us to achieve our goals. So one of the libraries we're going to import is called NumPy. So we're going to import, just type import NumPy as NP. This is a library that allows mathematical computations like linear algebra and other things. It is a scientific library and it is open source. Hit enter, and then we're going to import another library called Pandas. Import Pandas as PD. Pandas is a data visualization and manipulation library. It's also open source and it is widely used. And today we'll see how helpful these libraries are. Then we're going to import matplotlib. So we're going to plot matplotlib as PLT. And what this matplotlib is also a library, and it is a library, in fact, that's used for data visualization, 2D, 3D visualization. And in fact, it is so convenient that it generates images that can be used to publish in articles and other things. Then we're going to import another library. If you don't know what these libraries are, you shouldn't worry. But with time, we'll see what these libraries will be doing for us. Then we're going to import Seaborn. Seaborn is another library that sits on top of matplotlib. It's also used for doing advanced.
Hello, Ali. I think we have some people are asking for the link.
Okay.
Also they have missed. So if you can probably reshare the link again, and then people would, I think, pick up from there. Thank you.
All right, thank you. So the link this is the link. This is the link to Google Colab. HTTPS, you go to colab.research.google.com. If you hit enter, that will take you to where we are. So it should bring you to, so with that link, it will bring you to that page that we saw earlier on. And then on the page, you go down on the page, or I'll assume I've not done all this. Just for the sake of people that are just coming in, I'll close this and I'll just do it again. I'm here. Sorry for those of us that have already reached here. So I'm here and I'll click on new Python 3 notebook. It is here on at the bottom right hand corner. And with this, it opens a new Python 3 notebook for me. Then the first thing we have to do is to come and click on connect. Connect is on the top right hand corner. Are we here? Click on connect. So it is allocated resources for you. You'll be given 12 gig of RAM. And then if you want to use the graphical processing unit, which I said is a hardware that allows computation to be very fast. So we go to runtime, which is on the top right hand corner. It is the fifth tab on the top right hand corner. Click on runtime, then go to change runtime type. Then you can click on hardware. You can see hardware accelerator here is none. So now if you want to accelerate a hardware that is used for accelerating computation, Google gives us TPU and GPU, but for now, let's go for GPU. Then save. You see that connection is saying connecting, initializing, now connected. So we have our resources. So with this, this has helped us. Google has helped us with this Google Collaboratory. We don't need a computer. You don't need to do installations. Everything is installed. And in fact, I'm sure this is powerful enough for most of the work we'll do. So what we're going to do is we import some Python libraries. Like I told us, there are libraries that are required. So we're going to import some libraries. These libraries contain the functions that we're going to use to visualize our data, describe our data, and to even do machine learning. And so that's why we're going to import these libraries. So we'll start with import numpy as np. Then we're going to import, like I said earlier on, pandas. So we're going to import pandas as pd. Then we're going to import matplotlib. If you are with me, I would like it to be nice if you can be able to like type these things, and you can see Google Colab does this excellent thing of giving you suggestions. As you start typing matplotlib, you don't have to go on typing. It just gives you the option. Like I said, NumPy is used for scientific computation, like doing algebra, linear algebra, and other things. Pandas is used for data analysis. And matplotlib is used for visualization. It creates plots, 2D plots, 3D plots. Then there is Seaborn. And Seaborn is used also for visualization. It in fact sits on matplotlib. So it does advanced, it is used for advanced visualization functions. Then besides that, we are going to import our machine learning libraries. So from sklearn is the Python machine learning library. We are going to import. You don't have, for the meantime, I'm sure people will be thinking, what are these things we're importing? You shouldn't worry. And this is one thing about the top-down approach. So the top-down approach is that, model selection from sklearn dot model selection. You see, if you make a mistake or you forgot to type something, you don't see it highlighting. But once you see highlighted, it means that you are typing it right. Then we're going to import from sklearn, which is a library for machine learning. We're still going to import some few more things. And lastly, the thing we're going to import next is still from sklearn. I don't know whether this is visible to you. I'll still increase my zoom just in case these things are not visible on some small devices. So I've increased the zoom. Yeah, so we have imported many libraries, and I'm sure for most people here it's going to be strange that what are these things? You shouldn't worry, and this is one thing about top-down approach. The approach we're doing today is we're not going into the basics of learning what is Python, what is machine learning, what is no. What we're doing is we're going to solve a problem. So by the time we finish solving a problem, by the time we go from the top to the bottom, the whole picture just becomes clear. For anybody that is intending to take this further with this thing you're creating, you will have the chance to reuse it. And so that's the advantage. Once I finish typing this, there's a play button here. If you click on this play button, it just runs everything. So it's just like body this data, and the data has been sent to you via email. If you haven't forgotten, mine is here. It is the Boston housing data set. which is a CSV file. Do you all have this? If we all have this, we're going to put this onto our Google Drive. Go into your Google Drive. This is your Google Drive. So that is, if you are logged in onto your computer, that's why we said you need a Google account. If you are logged into your computer, go into your Google Drive, then create a directory, just new folder, and give it a name, data. Create a directory, data, then open the directory and drag in your data set. That's the CSV file that you were sent. The Boston Hill housing data set is a popular data set that has been used for that has been widely used in statistics and elementary machine learning. It is a very small data set having just 506 rows. There is some information on this. If you just Google the Boston housing data set, this is much about it. You could check this up after this webinar, but the most important thing to note is that it is an Excel sheet that has 14 fields. And all these fields are abbreviations. So if you opened it, it will look like this. We have CRIM up to MEDV. And what are these fields? If you want to know what these fields are, they are highlighted. Because it is a popular data set, once you write the Boston housing data set in Google, you see this come up. CRIM means per capital crime rate by town. So actually the data set it contains information, US Census Service concerning housing in the area of Boston. So it contains some information like per capital crime rate, proportion of residential land zone for lots over 25,000 square feet, and lots of other information. And the last field here is called the median value for owner-occupied homes. So it's just like the price of houses. So it is like these are data that determine the last field. The last field is number 14. So we don't have to worry. You don't have to worry. You don't have to know what this is or what specifically this is. But that's the data set we're going to use. Now, I assume that you have followed the description I said. You go into your Google account, that's G Drive, Google Drive. You create a folder called data, and you drag your Boston housing, the CSV into it. With that done, now we're going to load that on in our Google Colab. If you have reached this second cell, you see that if you are struggling getting from the first cell here after you have clicked on play, getting to this second stage is just a matter of clicking on code. Then once we're here, we are going to now type this command. You type from google.colab import drive. So this is going to connect us to our drive. Then come down and type drive.mount /mount drive. Notice the uppercase D here. You have to type it exactly like this. MNT is in lowercase. There is a front slash, not backslash, and there is a single quote. You should notice this single quote here. You must type it exactly like this. Exactly like this. Yeah. Then, with this, you will now click on Control Enter, or you just click on display. That is run the command. If you run the command, what this command is doing is it is connecting this workspace, this computer, Google Colab, to your Google Drive. It is trying to access your Google Drive to communicate to the directory that we're going to talk on. So what it is trying to do is to mount your Google Drive, but you must give it some access. So there's this URL. It says go to this URL in a browser. So just click on the URL. It will take you to a browser. And then when it takes you to a browser, you click the account that is connected to the data set. For instance, here I have 3 accounts. So I'll just connect it to the G Drive account that I'm using. So once I connect, I have to give it a permission. When you click on that, there's allow, click on allow, and then it brings me to this page. Let me expand this page so you see it clearly. Let me zoom it in. you have to copy this. So what you do is you copy these lines because it says, please copy this code, switch to your application and paste it in there. So you just copy this, go back to your application, that's the Google Colab, and then there's a field here, we just paste it here. So what this is doing is we're giving permission. And once you paste it, click on enter, hit enter on your browser, on your keyboard. It will take some time, but it will have mounted. So you see, mounted. It means that now this page is mounted to my Google Drive. So it means I should be able to access that directory on my Google Drive. Next, we're going to write another command. You should be getting used to this now. When you finish typing these commands, we run the commands, and then we came to this. To come to this cell, we click on code. Then from this cell to get to another cell, we click on code. Then here, what we do here is we are now going to access our data. Now you are going to see the importance of one of the first libraries that we imported, that's Pandas. Pandas is a library that makes it very easy for you to read CSV files, Excel files, and others. So with Pandas, there is a command which we type. We just write data equals to pd.read. Sorry, pd.read CSV. You see, it is even giving me the option. I'll just type read CSV. That's underscore, read underscore CSV. Then I'll then type mount, just like we did earlier on, MNT, uppercase drive, /, you type my drive. Notice in programming, we are quite critical about the case. When we type in lowercase, we mean lowercase. If we type in uppercase, we mean uppercase. If we type with space, we mean spacing. So here we've typed my drive. M is uppercase, and then there's a space, then the D is uppercase. There's a single space here, then type / data. So what this is doing is, it is going into your Google Drive. That's your drive. Because this is how your Google Drive is, my drive, then data, then the bostonhousing.csv. And that's exactly what we're going to do here. My drive, data, / bostonhousing.csv. And that command is going to read the data. What this is going to do is it will read the CSV file, the whole of that CSV file, this complete CSV file will be read into just a variable called data. For those of us who don't like hearing what is variable, you don't have to worry what's variable or whatever, but just assume that we're loading everything into memory of our computer. So having done this, I can easily click on play here or hit Control Enter, which is the same as this. And that has loaded our data for us. We have achieved we have just achieved one milestone. We've connected to our Google Drive. We have now loaded data. Having loaded data, the next thing we're going to do is to describe our data, to look at the data. How are we sure that the data has been loaded into this variable? So what we'll do next is you click on code to go on to the next code. But instead of clicking on code, we could do something even. We could make this Jupyter notebook more readable. We could just click on text. Here you could type what you intend to do next. So maybe I can just type data description or something like that. Data description. And in fact, I can make it bold. There's B here, just like Microsoft Office. You could make everything bold. Bold. So, sorry. I will type this data description, and I could highlight everything and make everything bold, and I could even change the text. I could do many things, and I can hit enter and continue typing. So that's why it is called a notebook. You are programming there, and you're also able to type things inside. So in the end, it becomes something that's very readable and clear. So even if you have forgotten what you did in this work, you could read it just like a notebook. So here I could write. Here we are going to see the loaded data. So having done this, the next thing is you could just go on to Control Enter as well. So when you hit Control Enter, you see that this goes like this. Sorry, the next thing you could do is you could just go to code. So it means that it has finished typing. You can see this is now becoming into a notebook. You have finished typing. You could go back here and do some formatting. For instance, you could hit enter and it just formats it. Then Having done that, you go to the next cell. I hope I'm not having any problem getting to the next cell. Whenever you want to get to a next cell where you want to write a program, you come up to the left-hand corner and type code, or you could just type Control+N. You can see there's the shortcut here, but you don't have to struggle. So the next thing is, now we want to describe the data. I want to see what we have just loaded. The first thing I want us to all write is, we want to see just some information about the data. So you could just write data.info. You can see how easy Python is. Data.info, because our data is in data. And data.info, if you click on the play button, see, if you are with me, you see this is some summary of our data. We opened the Excel sheet in the past. We saw that we have 14 columns and they have these titles, and that's the same thing you see here. You see the data columns, total of 14 columns, CRIM, and up to this. And it even tells us the data type, that they are floating point numbers, and so on. So it gives us some information. Next, click on code again. So it will take us to another cell. We could even print, so this has just given us an information about the fields. We could even print the first 5 rows, if you want, of the Excel sheet, just to be sure of what is there. So there, what you can do is type print, open bracket and close bracket, that's parentheses, then type data.head, and open bracket and close it, and just type 5. What this is saying is that print the first 5 rows of our data. And if you click play, you see this has just eligibly shown us this. And because it is a long, the number of rows are just too much, it just truncates it. But at least it shows us that this is the data we have. And if you are to open your Excel sheet, that's exactly what you see. Next, we'll click on code again. We're still describing the data. I hope we're not in a hurry. So here, the next thing we want to do is, there is something for most of us that are into data analysis. If you were to type data.describe, so if you were to write data.describe and just sit and run it, it will give us some very, very good information. To have a clear look at this, I'll reduce the zoom. See what we're seeing here. Just by that typing this single line data.describe, it shows the number of rows count. It says that this field has 506 rows, this one 506, and all of them have 506 rows. It gives us the mean, the average. That's in statistics. I'm sure all of us that we have some knowledge of statistics. So mean, it gives us the mean. For this row, the mean is 3.6. The mean for this one, this is very good, especially for us, for some of us that are into research. Just with this single line, we'll be able to see some clear information like the standard deviation. It even gives us the minimum value, that if you are to look at this row, this whole row for CRIM, if you are to look at it completely, what's the minimum value on that row, or in that column, on that field? In that column, this is the minimum value. So it gives us the minimum values. So with this, we just describe, we're able to see the 25th percentile, the 50th percentile, that's the median, right? The 75th percentile, that's the third quartile, right? And yeah, 75 percentile, sorry. And then we could even see the maximum value. So this is just with data.describe. And another obvious thing that you could do here is, if you click on code again, you could type data.columns. So this simply just gives us the number of columns we have. So it gives us all the columns. So you can see we have CRIM, and just like we have said before. This is enough for data description. There are many other commands you could explore that will describe your data. But if you are following me, you see that we have done a lot with data description. The next thing now we'll look at is visualization. To make our notebook more readable, like I said earlier on, let me zoom into this again so that you can see my notebook. And if you are doing it by yourself, I'm sure you'll be seeing it on yours, so you might not even have to look at mine. Click on text. Now, what we want to do is data visualization. So we can type data visualization. And you could bold this. And like I said before, you could come down and type many other things like here we will visualize the data and their relationships. That's the relationship between the fields. Having done that, we click on code. Getting used to it now. So now this brings us to data visualization. And the first thing we want to visualize is the distribution of our data. For instance, if you look at this data, each field here has a different distribution. I'm sure for some of us that come from scientific background, even those that are not into science, people that just did elementary statistics know that data has different distributions. We have the normal distribution. So sometimes you want to visualize the data. Is it normally distributed? Because if the data is normally distributed, maybe you want to do some specific things to it. So since each column is a different entity, we're going to look at each. We'll start with just a few. And for instance, if I wanted to visualize the distribution on the first column, that's the first column, which is CRIM. What I'll do there is, this is where one of the packages that we loaded, that's the second package. The third package, that's Seaborn. You see Seaborn in place. Seaborn is a very good library for this. So what we'll do is we could just type axis equals to SNS Seaborn.dist plot. Just this plot, just a single command. Then we'll call the data, but because the data is our complete data, and now we want to refer to just the first column. So here we're going to write data.columns. I'm sure this thing is it would be interesting, and if it is confusing, instead of giving up, don't give up, just go on. Let's see it at work. And the good thing is that if you're typing this on your browser, you have it anyway. And later on, you could even go and explore more, especially with Google today. You could just type some of these commands and see what they are doing in detail. But what we're doing here now is we're just accessing the first column. So if you type it right, notice there is a square bracket, data.columns, then another square bracket, then 0, then square bracket closes, another square bracket closes, then we'll close our parentheses. If you get this right, and we run the code, this shows the distribution. If it is normally distributed, I'm sure for some of us that are into statistics, a normally distributed data will have that dome shape. So this is the distribution of this one. And we could go on and even plot the distribution of all of them. But I'll just plot maybe the distribution of the first 4. Then I'll let you, after this webinar, to try play around to see if you could plot all of them. So for instance, if I wanted to plot the next 4, I could just type, and this is the power of using matplotlib. So we could just type something like axis 1, axis 2. Let me zoom into this so that for those of us that are copying what I'm doing, you can see exactly what I'm doing. Axis 2, axis 3. So I want to plot on 3 axes. Subplots. Notice it is subplots. There's another command that doesn't have the S. You must have this S at the end. Then we want number of rows to be equal to 1, and then we have number of columns to be equal to 4. And we could even give the figure a size, fixed size. We could give it a size. The good thing about this is that after this, you could go on and keep on learning. Then the clever thing I'll do here is I'll just write one command and then I'll just copy it across. So CNS.this plot, that's the distribution plot. Then data, you remember what we did? We then have a rectangular bracket. Be sure it is rectangular. Then data.columns. Then another rectangular bracket, put 0. So that's for the first field. And you wouldn't close this. After the square bracket, you put a comma and then call the axis that you want to plot it on. So I can easily copy this and do it again for the second field, the third one, and the fourth one. The second field is index 1. The indexing starts from 0, and the axis is axis 2. This one is index 2, axis 3. This is index 3, axis 4. And what this means is that index 0 is the first field here. Index 1 is this, index 2, index 3. So if you run this, what are we going to get? Let's see. Okay, we don't have axis 4. We only have axis 1, axis 2. I made a mistake here. There's axis 3, then axis 4. So if you run it again, nice. So this is what we have. Let me reduce the zoom so we'll be able to see the plots. So you see this is the distribution of the first one, this is the distribution of the second one. This is like a bimodal distribution. You could see the deep inside here. This is also, this looks like a binary distribution. So for those of us that are into statistics, this is also bimodal, we can say. And yes, so you could go on to plot everything. So this is the first thing. It shows you, it gives you the opportunity to visualize the data. Next, if you are with me and you're not still tired, we'll click on code. Then we'll look at correlation of our data. So if you write correlation matrix, and the single command we write is data.co. It is C-O-R-R. The R's are 2. So you could just type that, then open and close parentheses, and just type correlation matrix just to see what we have in our correlation matrix. So with these 2 lines of code, it is going to show us the correlation that exists between all 14 samples, all 14 fields, meaning that we'll see the correlation that exists between A and B. We'll see the correlation between A and C, A and D. It is going to be a matrix, and this is very interesting. If you were to click play and then reduce the zoom, let me reduce the zoom just for you to see. See, this has given us, can now see the correlation between. So what this is saying is that we're looking at the correlation between CRIM and CRIM. The correlation is 1 because we're just correlating it to itself. You could see some have a very low correlation value. So the CRIM to ZN, the correlation between them is this. So you can keep on and look around. We're getting somewhere with this. It might be less relevant to some of you, but just hang on. We'll see what this means. And in fact, we could even do something more interesting with this correlation. We could plot it as a heat map. If you are to click on code and then go to the next code, and now I can still plot this in a different way. If I wrote plot.figure, you should be able to follow exactly what I'm typing. Plot.figure, that's with matplotlib. I will define a figure size of 10 by 10. You can see I'm using all these parentheses are quite important. Then I said we're going to plot it as a heat map. So write sns.heatmap. You see the option just comes up. And then we just write correlation matrix because that's what is containing, is holding everything that we're going to view. And there are some few options. Just go hang on and write them. We want to annotate. So there's an option called annotate. Write true, and then write annotate again. The second option is annotate keys. So key size. So we'll just put curly braces, open and close curly braces. You can see in programming we have a different meaning for curly braces, a different one for rectangular, and even the normal parentheses. Then we'll put double quotes. You can even try with single quotes, but double quotes, then type size, then type colon and type a size of 10. You see what all this means after we run it. Then we'll write plt.show. With just these 3 lines of code, see what we achieve here. The correlation matrix will come out in a very good, in a fanciful way as a heat map. Look at it. Where we have, when it is bright, that is 1. You can see the highest value is very bright. So by just merely looking at this, what this correlation matrix, the plot, this heat map is telling us is that we can easily see that the correlation here, we have a correlation of 0.7. The correlation that exists between RM, that is this value here, RM, correlation that exists between RM and M, the prices. the price. You can see correlation between RM and price is about 0.69. This approximates it to 0.7. And there's another very high correlation, because in the end, what we want to look at is, these are prices. Like I told you, the 14th field is the price of houses. So we might want to see, how do these other 13 variables, how do they relate to our prices? And of course, if you remember in our statistics, and even in a real life scenario, where you have a very high correlation, tells you that there is more information. It is more liable to be used for further analysis. So you could look at RM, and the last field at RM will have 0.7. So RM is highly correlated to the price. And then there's another field, which is LS stat, is also highly correlated to price. So these two values have high correlation with the stat. Now, before we say we're done with visualization, let's visualize their scatter plot. Click on code. Now, we could click on code. So click on code. I wanted it to be below this, but I made a mistake. I was clicking just after the first one. So if you made the same mistake with me, just come into the second cell and click on code, so it will bring you to the next line. Now we're going to plot a scatter plot of just those variables that are correlated to the price, MEDV. So, and of course, if MEDV is the price, then it is going to be dependent or independent variable. Which one? Definitely MEDV should be the Y. So if it is the Y, it means that we could just say Y equals to, that's the, it depends on the other variables, since it is a price. So Y could be data. We are going to access it from our data. And what's the name of the column? So all you have to do is, if you want to access one column, you could just write the name of data. There's no dot, just square brackets. You can see it is even giving me options. I could just scroll these options and go to MEDV. Nice. And that's Y. Then the first X1, we said RM is highly correlated. We want to look at RM. So we could just scroll down to RM. And then the next variable we want to look at is X2. We could call it X2. So we're just trying to look at the only two variables that are very correlated to the price. So we'll just write data, square brackets, and then LSTM. It was LSTM, right? I could just type it, single quotes, LSTAM, TAT, sorry. Then I'm going to plot this, and this scatter plot. For the scatter plot, again, we're going to just define a fig. I'm sure by now you are getting used to using matplotlib to define figures. So we'll define a figure, and then the figure size, which is equals to, if you give it anything, play around with these values to see which one fits the best for you. Then axis 1, we're going to plot Y and X and axis 1, X1 and Y. So we could just say axis 1 is AX1.scatter plot. Sorry, before then, we have to define the axis. What's the axis? So the axis 1 is just a subplot. So axis 1 equals a fig that add subplot 1 to 1. What this 1 to 1 is referring to is, we have one row, two columns. So we want to just plot two things, one row, two columns. And one here, the second one means the first value there. So this x1 dot scatter, sorry. Yes, just type scatter and then type x1 y. You will see this. You see what it looks like. Then we could define another scatter plot, a second one, which is for the second axis. X2, we could define it as, just as we define this, fig dot add subplot 1, that's one row, two columns, and this is the second value, 1, 2, 2. And then we could just say axis 2 dot scatter. So this is for scatter plot, and then we could just write x2y. So after this, just come and write plt.show. If you are to run this, what are we going to get? Okay, so we made a mistake in our typing. So the mistake here is, it is saying that axis 1, okay, yeah, fine. So let's do this again, axis 1, subplot. Okay, yeah, so if we had to type this again, we have a typo in our typing. Axis 1 is equal to, instead of dot, axis 2 is equal to, so then if you run this, yeah, so we have nice scatter plots. And so with these scatter plots, we have, this is the first scatter plot and this is the second one. We're almost an hour gone, and we've not even started our machine learning part. Maybe we might have to stop here, but before we stop, let's add some labels to this. So our scatter plot now, this is the first scatter plot and this is the second one. You want to have a label for this, maybe a title and other things. So just come back into the code. At the end of axis 1, you could just write axis 1 dot set x label. So x label, that is if you want to label the x-axis. Maybe you want to say the x-axis is for axis 1. Let's say for axis 1, the x-axis is rm, right? And you maybe want to say, and the y-axis for axis 1 dot set y label, and you want to write something like prices or MEDV, just as it is in the Excel sheet. And then for the second one here as well, we could just copy this and paste them, and just paste them below axis 2, and then change this to axis 2. Don't forget to change this, and this is ls start. ls start, yeah. So with this, if you were to run this cell again, look at what we have. We have MEDV here on the y-axis and RM here and ls start, and this is so nice. And in fact, we could even do one other thing before we say we are done with the scatter plot. You could even add a title here and a title here. So you could just come and say axis 1 the title dot set text. So here we just remember, whenever we're writing strings, we always have these single quotes, or double quotes might even work out. Then you could just write scatter plot of MEDV against RM. And then for the second one, we'll copy and paste again to make our life easy. And there's the scatter plot of this against ls start. Run it, and there you go. So let me reduce the zoom. And for those of us that are following on, you could see how many good things we have done so far. Yeah, so this is what we've done so far. We've had almost an hour of data manipulation. What we have done so far, we've been able to look at how to get a computer that has a big RAM size and with Python installed with all the necessary packages without you having to struggle. And it just requires your internet and a Gmail account. And this is what we've done using Google Colab. And after getting the Google Colab, we imported libraries that we need for this. We've used some of these libraries, and there are a few that we haven't used yet. And then we got our data, which was a CSV file containing, you could also load an Excel sheet as well in the same manner. So we loaded this CSV file if you remember. And then after loading this CSV file, we described our data. And then after describing our data, we've been able to visualize our data. This is 1 hour. I wouldn't like to push us further. I was thinking that if we had enough time, we could have done the machine learning bit of the data. After seeing our scatter plots and all these interesting things, I was hoping that we could look at some other interesting things like the data and everything. But unfortunately, since time wouldn't permit, I think we will have to call this the end of the first series. We will be able to entertain some few questions, but we hope that we, in the near future, will organize another webinar. And then, since everyone now is familiar with how to use Google Colab, we're not going to waste time explaining how to do these things. We'll just delve into it straight, and then we'll just take our data. We'll still continue using this data, and then we'll run some machine learning algorithm to do some predictions and some interesting things. I hope so we'll be able to entertain a few questions. So feel free to send under the comment section to send some questions. Yeah, so this question says, how can we understand? This question says, how can we understand error codes in Python and make the correction? Yes, so to understand your error code in Python and to make correction is just read the error code. I'm sure it is daunting to see after you have run something, then it just falls over. And then it just gets so, it gets scary, especially when you see things not working out. So the advice is, if you can read the code, the lines of code, that's one thing. The lines of the error code always tells us what's the problem. And then secondly, you could do one other thing. The second thing is copy the error code and just paste it on Google. There's Stack Overflow. There are some very interesting websites that just solve the same, because whatever problem you are seeing, somebody will have seen it somewhere in the world. So just paste it in Google, and most times you have some very helpful advices there. And in fact, the more you do it, and I'm telling you, one of other thing I know and I've experienced over the years is that it is very hard to find anyone that will write a code that is bug free. So each time we write, we make these human errors, and we just have to keep on correcting ourselves and getting better and better by the day. We still have a few minutes to take a few more questions. Somebody said there was somebody saying, I'm getting error when loading the data. Unfortunately, I'm sure if you go back, we're going to upload this video, and if you were to go back to the video, you should be able to see step by step how we did our own. It is either you had a typing error. These are one of the most common things. So for instance, I will take you to, if you go to these lines, so this is the line where I loaded the data. So this is where I loaded the data. Make sure you type this exactly like this. From google.colab, import drive. Drive.mount, you must type it exactly like this. Upper cases, lower cases, bit cases, and everything in single quotes must be like this. And then when it comes up, it will show you this link. You click on the link here. That's this highlighted link. And then it will take you to your Gmail account. You allow access. Then you copy this code. It's simple. It just tells you what to do. You paste it here and then hit enter. Once you have done that, if you have gotten this site correct, that's you've mounted your drive onto this to the Jupyter notebook. The next thing is you type this line exactly like this. And what this is saying is that we are assuming that you have in your Google Drive, you have created a directory called data. So my Google Drive, which is this, this is not my Google Drive, this is my Google Drive. You can see this is my drive. I have a directory called data, and inside it I have the Boston housing.csv. So most times, honestly, it is either due to typing error or something of that nature. Yeah, so So having loaded data successfully, you should be able to go back and try everything we've done. How can we apply it? So this is another question. How can we apply to our day-to-day data analysis? So to apply to your day-to-day data analysis, this is exactly what we're saying. You should format your data in a CSV file and try and take it through everything we've done. Honestly, everybody's problem is quite different, but if I were you, I'll follow this series till the end. And while I'm following the series, I'll try and, in my mind, I'll be thinking of how my own data is. And so as a result of thinking of your own data and how your data is, you'll be now using whatever we're doing here and just transferring it there. And the good thing is, if you follow this with your computer, you should have that notebook with you. So it means that you could just go into the notebook, change the data, the CSV file that we put in there, and put yours, and then at least visualize it, describe your data and everything. We haven't gone far. We haven't done much. There are many other things we would love to do, but time wouldn't permit in this session, so I'm sure we'll be able to organize another session. So